cobalt. Let's look at francium is not fluorine. There we go, francium. So francium, is that a metal, metalloid, or non-metal? It's a metal, right? So we know it's shiny. We know it's malleable. And then those are a couple physical properties. What about chemical properties? What chemical properties do we have? Yeah, we know that they lose electrons. We also know that they form ionic compounds with non-metal ions. Okay. Calcium. Is calcium a metal, metalloid, or non-metal? It's a metal, right? So we can say, all right, that's the same thing as francium. We know that they're metals. You're going to have the same physical properties, the same chemical properties. Cobalt, metal or non-metal? Metal, so same. So on the quiz, you're going to see questions like this where it'll give you certain sets of elements, and you'll need to look at those elements and go, okay, first, what do I know about them? Are they metals? Are they non-metals? Are they metalloids? And then from there, you have to think, what properties do they have that are similar? Well, what if it said lithium, sodium, and potassium? Lithium, sodium, potassium. Like if you noticed that all three of those elements that it gave you belong to the same family, not just metals or non-metals, but alkali metals versus alkaline earth. What properties? So you got to look at those properties and be able to identify which ones are correct. Okay. Explain why alkaline metals, alkaline earth metals, and halogens are very reactive, and then draw a diagram to explain. So alkali metals, so you have three. You have alkali metals, alkaline earth, and halogens. Why are they highly reactive? So alkali metals have how many valence electrons? One. So they lose one valence electron. They lose one valence electron. This is easier than gaining 7. So since it's pretty easy to just lose one, that makes it highly reactive. In other words, it reacts with a lot of different chemicals. I mean, it's so reactive it'll just react with water. That's how reactive it is. If you look at alkaline earth, it's kind of the same thing, except it'll lose 2 valence electrons. So it loses 2 valence electrons, which is easier than gaining 6. And it's also easier than losing 3 or losing 4. So because of that, it's pretty reactive. Your halogens, they gain 1. So halogens gain 1 valence electron, which is easier than losing 7 or gaining 2 or gaining 3. So it's pretty easy to lose 1 valence electron or to gain 1 valence electron, to lose 2 valence electrons. That's pretty easy. That's why those are highly reactive. and then you could draw a diagram, which we've kind of done this already, but and then it could be attracted to anything really. But let's say that you have fluorine, and fluorine gains an electron, and when that happens, your fluorine has a negative charge, and your lithium has a positive charge. You think about magnets, right? Yep. So they're going to be attracted to each other. And that's how ionic bonding happens. You have positive charges and negative charges, and those are opposites, and opposites attract. And then the last post-lab question, we kind of answered with the diagram we just drew. Explain why halogens form compounds with alkaline metals and alkaline earth metals.
Like C number 6.
Basically, and just give a brief explanation. Yeah. So another way that I draw this sometimes is you have your lithium with one valence electron, your fluorine with 7. The electron from the lithium will come down to the fluorine because fluorine is highly electronegative, so it draws in that electron. And then when that occurs, then lithium is positively charged, fluorine is negatively charged, and then they are kind of drawn to each other, which gives you a happy molecule.